Drifting in the vast black sea of space are millions of silent travelers, asteroids, remnants from the dawn of the solar system. To most, they are just barren rocks. But to scientists, visionaries, and entrepreneurs, they represent something far greater, the next great frontier of wealth and survival. Each asteroid is a time capsule, untouched for over 4 billion years, carrying metals and minerals forged in ancient stars. Inside them lie the elements that built our world: iron, nickel, platinum, cobalt, gold, and water, not as liquid, but locked in rock and ice. Now, as Earth faces dwindling resources and an ever-growing hunger for energy and technology, humanity is looking outward. The same asteroids that once threatened our planet with extinction may soon become the key to our expansion. A trillion-dollar economy waiting in the silence between the planets. This is the story of how we might transform the debris of creation into the foundation of our future civilization, and of how the race for asteroid mining could redefine what it means to be a spacefaring species. The dream of mining the heavens is not new. In the late 20th century, science fiction writers imagined vast industries orbiting the Earth, refining metals harvested from passing asteroids. But what was once fiction is now entering the realm of possibility. The idea began with a simple realization: asteroids are rich, far richer than anything buried beneath Earth's crust. A single metallic asteroid just a kilometer wide could contain more platinum than humanity has mined in its entire history. Another could hold enough iron and nickel to build cities that orbit the sun. In 2012, private companies like Planetary Resources and Deep Space Industries ignited the first real wave of interest. They dreamed of fleets of robotic miners, prospecting near-Earth asteroids, extracting materials, and transporting them back for use on Earth, or for building in orbit. Though those early ventures faded, the dream did not. Today, major space agencies and billion-dollar corporations are quietly preparing for what many call the solar system's first industrial revolution. Between Mars and Jupiter lies the asteroid belt, a vast region containing millions of objects of every shape and size. Most are small, but some, like Psyche, stretch for hundreds of kilometers and may be made almost entirely of metal. NASA's Psyche mission, launched in 2023, will soon study one such world, a rare opportunity to examine the metallic heart of a planet that never fully formed. Scientists believe it could be worth $10 quintillion in metals alone. But we don't need to go that far to start. Thousands of near-Earth asteroids pass close to our planet every year. Some are rich in precious metals, others in water, which can be split into hydrogen and oxygen, the perfect fuel for rockets. With the right technology, these asteroids could become the refueling stations, factories, and supply depots of a new interplanetary economy. They are not just rocks. They are resources waiting to be awakened. Mining an asteroid is nothing like mining on Earth. There is no gravity, no atmosphere, no up or down. Machines must anchor themselves with harpoons, lasers, or nets, working in total silence as dust drifts endlessly into the void. The process begins with prospecting, identifying targets using telescopes and robotic scouts that scan for valuable materials. Next comes extraction, which may involve robotic drills, microwave ovens to heat and vaporize water ice, or focused sunlight reflected by mirrors to separate metals. Some missions envision 3D printing habitats and machinery directly from asteroid dust, turning the raw material of space into the architecture of human expansion. Others see a future where autonomous mining fleets roam the solar system, AI-guided swarms building a new kind of economy, one not bound by Earth's limits, but by the reach of our ambition. The technology is still young, but the direction is clear. We are learning not just how to survive in space, but how to build civilization there. The numbers are staggering. Even a small asteroid, rich in platinum group metals, could be worth hundreds of billions of dollars. A larger one might redefine global markets overnight. But the real value of asteroid mining isn't just what we can bring back. It's what we can build up there. The cost of launching material from Earth is immense, thousands of dollars for every kilogram. If we can source metal, fuel, and water directly from asteroids, we could build spacecraft, habitats, and energy networks without ever touching Earth's surface. Asteroid mining could become the backbone of a self-sustaining space economy, one where lunar bases, Mars colonies, and orbital cities are supplied by resources harvested from the stars. It's not just an industry. It's the beginning of a cosmic supply chain, a system that could support life, exploration, and commerce across the solar system. Among all the resources in space, one stands above all others: water. Not for drinking, but for fuel. Water, when broken down into hydrogen and oxygen, becomes the same rocket propellant that powers the engines of today's spacecraft. If we can mine water-rich asteroids, we could create refueling stations in orbit, places where ships traveling to the Moon, Mars, or beyond could replenish their tanks without returning to Earth. Such an infrastructure would transform space travel. It would make long-term exploration cheaper, safer, and vastly more efficient. A network of orbital depots could one day turn the solar system into a connected grid, a true interplanetary economy, powered by the same molecules that once filled our oceans. In a very real sense, the future of spaceflight depends on these ancient rocks, for within their frozen cores lies the fuel of civilization's next great leap. But for all its promise, asteroid mining remains one of the most daunting challenges humanity has ever faced. The distances are enormous, the risks high, and the engineering unprecedented. Robots must operate autonomously for years in deep space, exposed to radiation and micrometeorite impacts. Returning materials to Earth safely and cost-effectively remains a massive hurdle. And even if we succeed, the flood of new metals could collapse markets, destabilizing entire economies. There are also ethical and legal questions. Who owns an asteroid? Can a company claim it, mine it, and sell its riches? Or should those resources belong to all of humanity? International treaties, written long before asteroid mining was possible, offer few clear answers. Yet, as history shows, the boundaries of exploration are rarely set by law, but by those bold enough to cross them. The dream of asteroid mining has ignited a new kind of race, not between nations, but between visions. The United States, China, Japan, and Europe are all investing in technologies that could one day extract and use space resources. Private companies, from rocket manufacturers to AI startups, are developing the systems that might make it happen. NASA's OSIRIS-RX mission, which returned samples from the asteroid Bennu, proved that we can touch, collect, and bring pieces of another world home. It was a scientific triumph and a glimpse of the economic revolutions to come. In the coming decades, the first robotic miners may set out, their solar wings unfolding as they chase ancient rocks across the darkness, heralds of a new era where wealth is not found on Earth, but among the stars. If asteroid mining succeeds, it will change more than space. It will change Earth itself. Imagine a future where rare metals no longer need to be torn from fragile ecosystems, where industrial pollution fades because the raw materials of technology come from space. Imagine an Earth allowed to heal, supplied by resources drawn from beyond its skies.